FPGA mezzanine cards, or FMCs for short, are being used to accelerate productivity, reduce design time, and enable all programmable solutions for hardware and software development. As you may already know, the FMC specification, which is known as the VITA 57 standard, was designed to provide a standard mezzanine card form factor and modular interface to an FPGA on a baseboard. So what does all this mean? It means prototyping with an FPGA is a whole lot easier due to the plug-and-play nature of baseboards and FMCs. Today, FMC connectors come standard on all Xilinx baseboards, and along with our strategic partners, Xilinx offers nearly 100 FMCs that plug directly into our baseboards. Now let's take a look at a couple of really cool demos using FMCs. This is our Xilinx 7000 SoC video imaging demo. Great for exciting applications like machine vision. We've got a video signal recording the ping pong ball's movements. You notice the lines on the screen following those movements. The video signal comes from the camera into the Avnet FMC module and then onto our ZC702 baseboard. We use the Xilinx 7000 device to process the image and then output the video signal back over HDMI to our display. This is our broadcast video demo, which is based on a Revium Spartan 6 consumer video kit. We've got video coming from the camera, running through one of the SDI connectors, onto the FMC card, and finally onto the Spartan 6 FPGA baseboard. Spartan 6 device processes a signal and transmits the video signal back out on the other SDI connector. The FMC specification was developed in 2008 by a consortium of companies including end users, FPGA vendors, and VITA, a nonprofit standards organization. Xilinx was an early adopter of the FPGA specification, and as I mentioned earlier, FMC connectors are now included with every Xilinx 7 series and 6 series baseboard. Xilinx is just half of the equation though. We've also got a lot of great partners designing FMC modules and reference designs to interface with our baseboards. Now let's talk about what's happening between the baseboard and FMC modules that makes the solution so valuable. Depending on the complexity of the design, there are two different pin count options. The low pin count connector offers 160 pins. And this includes 68 single-ended or 34 differential IOs, one transceiver pair, and a series of clocks, JTAG, I2C, with power and ground lines interspersed throughout. The high pin count connector offers 400 pins, including 160 single-ended or 80 differential IOs, 10 transceiver pairs, and the clocks, JTAG, I2C, power, and ground. And because the baseboards offer different pin count options, application-specific FMCs can be used to get started designing immediately. Here's an example of two FMC connectors with our Kintex KC705 FPGA baseboard. The high pin count connector is on the left, where you'll notice every row of pins is populated, and on the right is the low pin count connector with 160 pins. The combination of FMCs, Xilinx baseboards, and reference designs allows designers to quickly and easily prototype complete solutions for a wide variety of applications, including things like software-defined radios, video imaging, high-speed data transfer, and motor control, just to name a few. The next step is to visit xilinx.com/FMC, where you'll see a complete listing of FMCs that connect to our baseboards, in addition to the parametric specifications that can help you identify the right FMC for your design.